Hello my friends, welcome back to this implementation and mostly welcome to part 3, training the CNN. In the previous tutorial we built the brain, which contained the eyes of the AI, thanks to the convolutional layers, and now we're going to make that brain smart with that training of the CNN on all our training set images. And at the same time, as you see, we're going to evaluate our same model on the test set over the epochs. We're going to train our CNN over 25 epochs, and at each epoch we will actually see how our model is performing on our test set images. So this is a different kind of training as what we did before, because we always used to separate the training and the evaluation. But here this will happen at the same time. That's because we're doing some specific application, which is computer vision. Alright, are you ready? Let's do this. Let's start with the first step, compiling the CNN. Alright, so in a new code cell, we're going to compile the CNN, meaning we're going to connect it to an optimizer, a loss function, and some metrics. And, well, here once again we're doing binary classification, and so, very simply, we're going to compile our CNN exactly the same way as how we compiled our ANN in the previous section. Because indeed, we're going to choose once again an atom optimizer to, perform stochastic gradient descent to update the weight in order to reduce the loss error between the predictions and the targets. Then we're going to choose the same loss, the binary cross entropy loss, once again because we're doing exactly the same task, binary classification. And then same for the metrics, we're going to choose the accuracy metrics because that's, the most relevant way to measure the performance of a classification model, which is exactly the case of our CNN. And therefore, to compile the CNN, well, it's going to be a piece of cake because indeed we're going to do exactly the same as before. So we're going to start by taking our CNN, from which we're going to call the compile method, which will take as input, well, first our optimizer, which will choose to be the atom optimizer, then the loss function, which will choose to be the binary cross entropy, all right, and finally, final argument, the metrics. We will choose only one, but remember we have the choice to take several of them, but just the accuracy is fine, and therefore in these pair of square brackets, we're going to input in quotes, well, that accuracy. And done, this compiles successfully the CNN to the optimizer, the loss function, and the metric. So exactly the same as before. However, now to train the CNN on the training set and evaluating it at the same time on the test set, well, it will not be exactly the same as before, but once again, very, very similar. Let's check this out. Let's create a new code cell. And now you can actually guess the first two steps. They're always the same. The first step is to take, of course, our CNN, from which, and that's the second step, what method do we need to call here? Well, once again, this never changes. This is, of course, the fit method. The fit method, which as always will train the CNN on the training set. Okay, so this time, what are going to be the inputs? Well, the first input is always the same. It's going to be, of course, the set, the data set on which you're going to train your model, here the CNN. And that's, of course, the training set. And the name of the parameter for that is simply x, and therefore we'll specify x to be, our training set. That exact same training set which we created in part 1, right here. That training set. That training set to which we applied this image data generator tool to indeed perform image augmentation. Alright, so that training set, that's the first input of our parameter in this fit method. Okay, then next parameter. Alright, so the next parameter is this time, the difference with what we did before. So it has to do, of course, with the fact that we're not only training the CNN on the training set, but also evaluating it at the same time on the test set. And that second parameter corresponds exactly to this. We have to specify here the validation data. That's the name of the parameter, but that's, of course, the set on which we want to evaluate our CNN. And that's, of course, a test set. That will be the value of the parameter. But the name of that parameter is, as I just said, validation underscore data, and this is equal, of course, to the test set. once again, that exact same test set which we created here in part 1 when preprocessing the test set, this one, to which, of course, no transformation was applied, only feature scaling. Okay, so test set, good. And now we have one final argument, which is, of course, you can totally guess what it is, right? This is the inevitable argument when training a deep neural network. I'm talking, of course, about the epochs parameter, which is the number of epochs. And, well, to justify to you which number I chose, well, I actually started with 10 epochs, and I noticed that the accuracy was not converging. So then I tried with 15 epochs, because you're going to see that one epoch is actually pretty slow. It's actually a bit long. I mean, much longer than the epochs in the training of our previous neural network, the ANN. So I started with 10, it was not enough, then 15, still not enough, still not converging, and then 25, and 25 was perfect. I had an accuracy that pretty much converged. Not only on the training set, but also on the test set, you'll see. So for the number of epochs here, we're going to choose 25. Feel free to increase it if you have time, if you want to let your computer run for an hour or more. With 25 epochs here, it will be fine. It will just take 10 to 15 minutes. So that will be all good. We'll get our results pretty fast. All right, and well, actually that's it. That's only what we need to train our CNN on the training set while evaluating it on the test set. So perfect, we smashed part 3 and we can now already move on to part 4 where we're going to make our single prediction, which I remind will consist of deploying our model on the 2 images of the single prediction folder. This one for which, of course, our model will have to recognize that there is a dog, and this one where our model will have to recognize that there is a cat. So let's hope that it is right, but we won't have the predictions in the next tutorial. We will have them in the one after that, because remember, we're going to run our implementation from Jupyter Notebook, because we can't do it in Google Colab. The dataset is too big. All right, so, well, as soon as you're ready for part 4, let's do this together. And until then, enjoy machine learning.